everyone, and welcome back to my online teaching platform. We are still learning how to differentiate implicit function. We have been given an explicit function, and we have to show that 2 multiply x cubed plus 1 in bracket dy dx is equal to negative 3x squared y. Now, looking at the given part of the question, the second part of the question, you could see that we are to show that 2 multiply x cubed plus 1 dy dx is equal to negative 3x squared y. You see that what is given is in implicit form. The answer given is in implicit form, but the original function is in explicit form. So we have to rewrite the original function as an implicit function. All right. So if I have the function which is y is equal to 4 divided by the square root of x cubed plus 1. This implies that I have to cross multiply so that I can get my implicit function. So I have here to be y divided by 1. So when I cross multiply, I'm going to get y multiplying the square root of x cubed plus 1. Then 1 will multiply 4, and that will be equal to 4. So this becomes my new function. All right, so I have my new function as y multiplying the square root of x cubed plus 1 equal to 4. So we can now differentiate the implicit function. Now, looking at the first part of the equation, that is the left-hand side, we could see that we have an expression with y and another one with x multiplying each other. So we are going to have a product of the two. So this should tell you that you should apply the product rule. So we have our product rule to be our dy dx equal to v du dx plus u dv dx. What does it mean? It means you differentiate one and you maintain one. After that, you now differentiate the one that you have maintained in the first part, and you maintain the one that you have already differentiated. So we are going to apply the product rule here. So let me clean this one. I'll clean this particular one. So we are going to apply. So we need to get our components. So my y is u. Then I'll take the remaining factor of the term to be my v. All right. So we are going to differentiate our u. So u prime. Then you maintain the v plus you maintain your u and you differentiate your v. So we come u multiply v prime. Right. So that is the rule that we'll be applying at the left-hand side of the implicit function. All right. So let us differentiate our y. You differentiate your y, since the y is a dependent variable. When you differentiate it, you are going to get 1. Then the result will be multiplied by dy dx, which is the same as y prime. All right. Then plus you maintain your u, which is the y. So you maintain y, then you differentiate our v. So we are going to differentiate our v, which is our v to be the square root of x cubed plus 1. So we need to differentiate this one. So let us find dv dx. Let us find our dv dx. We know that it can be written as x exponent 3 plus 1 in bracket having an exponent of 2. Having an exponent of half. Having an exponent of half. So when you are differentiating, you bring down the power. So let us bring it here. It's going to be half. We bring down the power. Then you maintain what you have in the bracket, which is x exponent 3 plus 1. Then you bring back your power. You reduce the power by 1. So you are going to subtract 1 from the exponent half. All right. then times the derivative of what we have inside, which is x cubed plus 1. So when you differentiate x cubed plus 1, you are going to get 3x squared. So you are going to get 3x squared. All right. And that will be the derivative of the v. So let us continue. Now we have here to be everything equal to 4. But when you differentiate the 4, you are going to get 0. All right. So here we are going to get 1 times y prime. 1 times y prime. But we have omitted something here. We didn't bring the v, the original value of v, after differentiating. So let me clean it. So when we differentiated the u, which is the y, we had 1, then multiplying dy dx, which is the same as y prime. Then you bring the original v value, which is the square root of, you omitted that one. So which is the square root of x cubed plus 1. All right. That is okay now. So 1 times y prime will give us y prime. Then multiplying the square root of, so we are going to get y prime multiply the square root of x cubed plus 1. All right. Then we move to the next side. Here we have half. So we can multiply this by this. We are going to get 3 out of 2 x squared multiplying this y. So we are going to get 3 divided by 2 x squared y. Then in bracket we have x cubed plus 1 having an exponent of negative half, because half minus 1 will give us negative half, all equal to 0. So we continue. We have our y prime multiplying the square root of x cubed plus 1 plus 3 out of 2 x cubed y. Now, here we have x cubed plus 1 in bracket having an exponent of negative half. So we need to change the exponent to positive. So we need to reciprocate this particular expression, x cubed plus 1. So which is the same as x cubed plus 1 over 1. So we are going to reciprocate it. So it's going to be 1 over x cubed plus 1 in bracket having an exponent of positive half, all equal to 0. All right. So we continue to simplify. We're going to get our y prime multiplying the square root of x cubed plus 1 plus. Now you can see that here we have a power of half, so which is the same as a square root. 1 exponent half is the same as 1. So the denominator exponent half will give us the square root of what we have over here. So we can rewrite it as 3 out of 2 x cubed. Sorry, here is rather x squared. It's x squared, not x cubed. So let me correct it. 3 out of 2 x squared y. All right. Then it's going to be multiplying 1 out of the square root of x cubed plus 1, all equal to 0. All right. So in this case, we are going to get y prime multiply the square root of x cubed plus 1 plus, then we simplify this. The numerators will multiply each other. So we are going to get 3x squared y divided by 2 multiplying the square root of x cubed plus 1 equal to 0. All right. So now what are we supposed to do? So we just need to transpose, since we are to show that, let's go back to the question. Since we are to show that 2 multiplying x cubed plus 1 in bracket dy dx is equal to negative 3x squared y, we have to be looking at this as we work on the given function. All right. So we need to transpose the expression without the y prime to the right hand. So we have y prime here multiplying square root of x squared plus x cubed rather plus 1 to be equal to negative 3x squared y divided by 2 multiplying x cubed plus 1. Alright. So now we can cross multiply. Since we are to show, you need to be watching what is given. So you will see that this expression here is also here. Alright. So we need to cross multiply this expression. The term here is over 1. So when you cross multiply, we are going to get y prime square root of x cubed plus 1 multiplying 2 square root of x cubed plus 1, then all equal to negative 3x squared y. So you can see that we have our negative 3x squared y at the right hand side as we have in the given question. All right. So this and this have the same base. So we just need to add their powers. So it's going to be our y prime multiplying x cubed plus 1 exponent half, then times 2 multiplying x cubed plus 1 also exponent half because of the square root equal to negative 3x squared y. So this and this are the same. So we add the powers. You have y prime. So we can bring the 2 to the other side of the y prime. So we are going to get 2y prime. Then we have this and this having the same base. So it's going to be x cubed plus 1. Then you add the powers. So half plus half indices all equal to negative 3x squared y. All right. So when half is added to half, we are going to get 1. So that will give us 2y prime, then x cubed plus 1 exponent 1. It's not compulsory to write it. Equal to negative 3x squared y. All right. So we can now rewrite this as our 2 multiplying x cubed plus 1, then y prime equal to negative 3x squared y. And we know our y prime to be dy dx. So 2 multiplying x cubed plus 1 dy dx is equal to negative 3x squared y as it is given. So we have now shown that 2 multiplying x cubed plus 1 dy dx is equal to negative 3x squared y. Thank you for watching, and do not forget to subscribe to my YouTube channel, Math with Ebefa. Bye.